Hello my dear students and my colleagues. Welcome back to my channel, that is Spark Virtual Academy ASCO. Do not forget to subscribe and like my channel to get the latest updates about the new lectures that I'm going to deliver. And in the series of this subject, chemistry, we are going to learn the laws of chemical combination today. The first law of the chemical combination is the law of conservation of mass. As the word refers conservation, it's taken out of conserve, which means remain same. However, in the law of conservation of mass, it is stated that the mass can neither be created nor be destroyed in a chemical reaction. However, it undergoes some changes. Its states are being changed. For example, if we took a piece of wood and we start burning it, initially it was a solid and its shape was as a wood, and later on it becomes coal, and after coal, if we burn it more, it becomes ash. So the mass was not destroyed there. Landolts was a scientist who carried an experiment to prove this law. He took a H-shaped beaker, as you can see here in this picture. He took such type of the beaker in which he placed two different chemicals from two different corners. From the first corner, he placed the silver nitrate, and on the other hand, he placed the hydrochloric acid. Before performing the experiment, he measured the mass of this beaker. After measuring the mass, he started to shake this H-shaped beaker. When he shaked, the new components were produced there. And after shaking, and when as a result the new components were being absorbed here, he again measured the mass of this beaker, and he found that the mass was same as it was before the experiment. So this experiment proves that the mass can neither be created nor be destroyed. However, it can be changed from one state to another state in a chemical reaction. If you have any question regarding this law of conservation of mass, you can put the question in the comment box and I will try to answer you all. Okay, my dear students, now we are going towards the next law. There is law number 2, and it is known as the law of definite, or we can say there the law of constant proportion. This law states that a given chemical compound always contains the same elements in the exact same proportion by mass. In simple words, we can say that if we have a chemical compound and if it exists in different states of matter, either it is solid state, either it is in liquid state, or either it is in the gaseous state, the proportion of the atoms, the proportion of the elements would remain same in each sort of the state of matter. Let's take an example of water H2O. If we take the ratio of H2O molecules by mass, you can see here there are 2 elements of the hydrogen, and by mass it becomes 2 grams of H2, whereas the mass of oxygen is 16. And if we simplify it, we get the ratio of 1:8. It means wherever in any state, if water molecules are present, the ratio of hydrogen and oxygen by mass will remain same, and that will be 1:8. It means one molecule by mass, 1 molecule of hydrogen would mix with the elements of the oxygen by mass. Okay, so we can say that in any state of the water, the ratio of oxygen and hydrogen remains same. Okay students, so welcome back again with the third law, and the third law is known as the law of multiple proportion. In the law of multiple proportion, it is stated that if we have two elements and they are forming more than one compound between them, then there must be one element whose mass is fixed and it combines with the second element whose mass is changing. However, both the elements are forming two different compounds. Then the ratio will be the simple multiple of some whole numbers. Let's take an example. If we have carbon and if it combines with one oxygen, then it forms carbon monoxide, as you can see here. Now here, the ratio between carbon and oxygen by mass is 3:4. It means if 3 grams of carbon combines with the 4 grams of oxygen, then carbon monoxide is formed. However, the same ratio of carbon, it means 3 grams, can also be reacted with the two molecules of two elements of oxygen, as you can see there, and it forms carbon dioxide. If we take the ratio of carbon dioxide, then here the ratio of carbon becomes 3, however, the ratio of oxygen becomes 8. It means it is the multiple of the small whole number. So it's clear that the fixed ratio of one element can react with the other element into different proportions. However, they form the different compounds, but the ratio of the fixed compound remains same. Okay, students, the last law of the chemical combination is the law of reciprocal proportion. Reciprocal proportion. Excuse me. So, it states that if two different elements combine with the fixed mass of one element by mass, then what happens there? You can see there the ratio of masses in which they do so, they combine with each other. It would be either same by mass or it would be a multiple of the mass. Okay, it will be easier by understanding this example, as you can see there. We have 3 different compounds here, as you can see here. We have hydrogen, carbon and oxygen. Let's take an example. If carbon and oxygen, they both react with the fixed ratio of hydrogen, and the fixed ratio of hydrogen here is 1. If hydrogen reacts with the oxygen, then it forms water, as you can see here. And if the same hydrogen reacts with the carbon, and it forms the methane gas. If we take out the ratios here, the ratios here would be 1:8. It means 1 gram of hydrogen reacts with the 8 grams of oxygen to form this, and the same 1 gram of hydrogen reacts with 3 grams of carbon to form the methane. So that's why this is known as the reciprocal proportion, because the fixed mass of one compound can react with 2 different compounds to form 2 different compounds. If we take the carbon as the fixed element, so you can see there, if carbon reacts with hydrogen, it forms methane gas, and if carbon reacts with oxygen, it forms carbon dioxide gas. If we take the ratios here, the ratios between carbon and hydrogen becomes 3:1, and the ratios of carbon and oxygen here becomes 3:8. It means the fixed ratio of carbon means 3 grams of carbon can react with 1 gram of hydrogen to form a different compound, whereas the same grams of carbon, 3 grams, can react with 8 grams of oxygen to form a different compound here, as you can see there. Similarly, we can move towards oxygen as well. If we take the oxygen as fixed, so oxygen can react with hydrogen to form water, and it can react with carbon to form carbon dioxide. If we take the ratios again, the ratios of hydrogen and oxygen are 1:8, and the ratios of carbon and oxygen are 3:8. So you can see there, the fixed ratio of oxygen is there, that is 8 grams, 8 grams of oxygen reacts with 1 gram of hydrogen to form a different compound, whereas the same 8 grams of oxygen reacts with the 3 grams of carbon to form another compound. So that is why that is known as the reciprocal proportion. I hope you loved and enjoyed and learned a lot from today's lecture. It was about the laws of chemical combination. If you have any query, you can put your question, your query in the comment box, and I will try to answer you all. Till the next lecture, see you. Bye-bye.